Hello everyone, we are Team 1, and I'm Sham, the team leader of Team 1. And today we are going to talk about a book, Brief Answers to the Big Questions, written by Stephen Hawking. And first, we need to say sorry to you guys, all of you. And there are some troubles on our sheet. And our names are vanished, so we need you to write down our names in it. Sorry. And I'm Sham. And this is Zio, Liu Zihao, and Benny, Wu Guoyi, and Robert, Yang Chenxun. And at first, as we all know, Stephen Hawking is an outstanding scientist. In spite of his disability, he still became the most influential person in the world. And since I majored in physics, I really appreciate him a lot. In his early life, he had found an infinite talent in the scientific area. So, however, when he was 21 years old, he got an illness called amyotrophic sclerosis, 就是那个渐冻症. So, but in spite of this, he still tries to do his best to concentrate in his study. So he became the best scientist of all time. And this is our outline. Okay, and this is the first question he brought up. Does God exist? And I directly said the answer. He said no. To him, the genuine God is science. And it may sound rational in some, as everything in the world are associated with the science. And then the second question is, how does the universe emerge? Generally speaking, the universe, it all started with a condition with high temperature and high density, and suddenly it exploded. And the phenomenon is called the Big Bang. And today, our universe are the development of the Big Bang through billions of years, about 14 billion years ago. Yeah. And next, Benny is going to talk more about the book.
I will introduce two topics, aliens and fortune telling. To begin with, we talk about the difficulty of cultivating life. Life is mainly composed of carbon atoms because of its various chemical properties. But the existence of carbon atoms should meet some conditions. One of them is that it must accurately address its physical constants. For example, its electric charge should be precise, satisfying the dimension of space-time, or the atom will be unstable and destroyed. Another obstacle is time. The longevity of sun is about 10 million years. Then it will be a red giant, 红巨星, devouring all the planets near it. But on normal planets, it needs to take about 7 billion years to develop simple life like bacteria. So it is likely before the intelligent life appear, their home has been devoured by the star near them. The appearance of humans sounds like a miracle, doesn't it? However, Hawking doesn't think so. By entropy principle, we don't need to be too surprised at these facts, because if the universe is not like the universe now, there aren't human discussing it. This principle is so complicated, so we don't talk more about it. But to put it briefly, we can say that there is still a little chance to find aliens. But why we don't find them? In Hawking's opinion, he thinks the reason why we don't find them is that their home is too far. So in the author's opinion, he denies the possibility of UFO since it will be a big and unpleasant issue if they truly appear, just like Aboriginal inhabitants in Americas meet strong and evil Spanish enemy. Then the other is fortune telling. It has long been a hard thing in movies or novels. Due to the Planck's law, if we can know all points, velocity, and position in the universe, we can calculate our future. But uncertainty law tells us 测不准原理. We couldn't know them, both of them at a time. And if we take black hole into consideration, the situation will be even worse because we even have difficulty in observing the black hole, not to mention to know its velocity and location. So, in short, we are unable to predict our future. Then here's a video to know how extensive is the universe, so we can understand that there is still little chance to find alien. Then Leon will show you the secrets of black hole.
Okay, next question is, what is inside the black hole? So first, we must know what is black hole. These two images are different aspects of black hole. Now, why do they look different? Because assume that this is black hole. If we look on the top of the black hole, we will see the picture like this. But if we look in front of the black hole, because the light behind the black hole will bend by the black hole because of the strong gravity. So the light will appear like the circle. Yeah. And this one is the very first image of the black hole in the human history. There is M87 galaxy in the middle of the M87 galaxy. Okay, next. So I'm going to tell about facts about black hole. Imagine what if you pull into by the black hole, what will happen? Because the strong gravity, the leg, the gravity and the leg is stronger than the head. So you'll be pulled very low in a small black hole. But if we pull into by a big black hole, the gravity is too strong. So it will not be, so the gravity is all the same in the leg and the head. And next, we'll see the jet of the black hole. But why will the jet be so long? Because it's in quantum theory, the positive energy particle and the negative energy particles will emerge in a vacuum, and they will appear. But the negative energy particles will be pulled into by a black hole. So the positive energy particles will be boosted and fly away the black hole. So it will appear the jet. And next is the entropy. Entropy is mean messy, how messy the space is. So if it is really messy, the entropy is very big. And because so if we have an egg and it is broken, the entropy will become bigger because it's messy than the original egg. Okay, so the black hole will suck in many things, so its entropy will be very large. Okay, next. Okay, next, time travel. Is time travel possible? So first, we are going to talk about Einstein. He published the Journal of Relativity in 1915. And this is an equation, but you don't need to know about it. His main theory is that gravity will bend the space-time. So if here's the star, if there is no the planet, the starlight will go straight line. But if here's the sun, the line will be bent. So we'll see the path will be bent by the sun. So we'll see that the sun is here, but his place is here. So it's a fact. Next. Okay, now next is I'm going to talk about wormhole. Okay, so imagine you want to travel from here to here. Okay, it's a long distance, right? So wormhole is that it will bend the space. So we only need to walk this small distance. But in two dimension, this is a circle. But in 3 dimension, it's the space-time. It will look like a sphere, a ball. So this is actually the wrong image. This is the truth. It will appear like a sphere in the space, not really a hole. Okay, next. Next is paradox. If you time travel back to past and you kill your grandfather, will you exist in the now? In now? Huh?
Say that again, please.
Oh, if you travel back to the past and you kill your grandfather, will you exist now? What do you think? Huh? Do you understand? So you think you will exist or you will die?
It depends on when you kill your grandfather.
Huh?
If your grandfather and your grandmother married and they have your offspring, maybe you will is extent. If you kill your grandfather
Yeah?
before, you travel.
No,
back,
you
right?
travel back to the past and you kill your grandfather. So your father won't exist, right?
Yes.
And
What
you
is
will
what
not
you
exist,
said.
right?
Yeah, that's what you said.
So do you think you will exist now?
I think possible not exist.
Why?
Because my grandfather is being was being killed and it impossible to reborn my father with my grandmother, and so maybe by then I won't exist.
The answer is no. You will exist. Because the Hawking, he had a hypothesis called time protecting law. It will assist the time police that will stop you killing your grandfather. Okay, right. It's very weird, right? So you really, so it's called a causality. Causality. The thing that happened must happen. You cannot change the past. The thing that must happen might happen. Okay, next Robert will tell you more about that.
Thank you, Zio. I'm Robert Yang Shenxun. Now we'll be talking about chapter 8, 9, 10. Chapter 8, what Stephen Hawking asks is, should we explore the space? Next. He gave the, in his book, he gave the answer. He says that it's just right here. Not exploring it would be like survivors of a sun ship refusing to leave the lone island. As the living space and natural resources stream in Earth, it makes sense to explore the space, just as Columbus discovered the new continent. The cost of exploring the space will not be small. However, Stephen Hawking thinks that we want to take out about 0.25% GDP of the total global GDP. So Stephen Hawking thinks that it's a worthy investment for our descendants. Next. So how do we do it? Scientists have been trying to find habitable planets in the Goldilocks zone from other star systems. The nearest star system that's habitable is Proxima b, which orbits around the red dwarf star Proxima Centauri. However, we are unable to send humans out by rocket into space right now, as it's impractical. The star system Alpha Centauri is 4.37 light years away from Earth, which is 40 billion kilometers away. So with our current technology, it's impossible. So how are we going to achieve this feat? So the scientists devised the Breakthrough Starshot project. In this project, we'll send nanosatellites, coat the star chips, into space by using star cells as the propeller. How the star cells work is that solar photons will basically it uses the radiation pressure from solar photons, and it will propel the light cells, which will move the nano satellite starships. Okay. And how fast does the starship move? It can go as fast as 100 million kilometers per hour, and it will take only about 20 to 30 years to reach Proxima b, and 4 years to send a message back to Earth. So in this way, the scientists can know at least what are facing us in the space in their lifespan. However, there are also some technical difficulties, as you have to find the right material to build the starship so that it won't get burnt out while traveling out. When something is going out the ozone, the friction will cause heat, and the thing will burn out if the raw material is used. And there's also the space particles. Yes. Next. So the Goldilocks zone is where it's not too hot or not too cold, and it's just the right temperature for the organism to live. Next. This is basically what the Breakthrough Starship project is. Yeah. Next. This is a Starship. Yeah. It's basically a spacecraft with all the gadgets but shrunk to nano size. Next. Yeah, this is how the light cells work. Those are photons. And if you don't know what radiation pressure is, you can put your hand under a lamp, and if you feel that you'll feel heat, and that's the pressure. Yeah. Next. I'd like to share a movie. It's called Interstellar. 星际效应 in Chinese. You talk about space exploration and space colonization. You even talk about what black hole Zero said earlier, and the fourth dimension. Next, in chapter 9, Stephen Hawking talked about artificial intelligence. First, I'll talk about the pros of artificial intelligence. It's convenient. I don't think I need to describe how convenient it is. As you can just tell, like you have Siri on your iPhone, you can just instruct the AI to make a schedule for you without really typing all the schedules in yourself. And many factories use AI to simplify and speed up the process of repetitive work. Yeah, it saves expense and time. And AI also helps in many professions, such as the medications, because due to its speed and accuracy, it can help doctors perform surgeries with higher accuracy and speed to reduce the risk of their basically that. Other applications that Stephen Hawking talked about is personal duplicate. Basically, you're duplicating yourself. You're making yourself an AI. So how this works is if let's say you're tired like today, and you really wanted to complete a task, you can make yourself duplicate your AI to do it. Yeah, but it's just something that might be applicable in the future. That allows you to multitask. And the next is virtual character, which means that if let's say AI is improved such that it can think and act like humans, then Stephen Hawking thinks that the future idol we see today might not be Korean pops or AKB48. It will be like AI idol. Yeah, this. This is an actual product from Japan. It's called the Gate Box. basically is, yes, in the near future, you may see Hatsune Miku greeting you when you come home and helping you to do some stuff as well. Yeah. Basically, it's mixing AI with virtual characters. Next. Now we're talking about the cons of AI. There will be a rising rate of unemployment as repetitive jobs will be replaced by AI. So yeah, there will be unemployment. And there will also be a misuse of AI on, let's say, weaponries. So what happens if AIs are used in weapons? So the weapons will be much advanced and deadlier. It may cause an outbreak of war, something that both of us don't want. And there will be a high possibility of AI surpassing humans. According to the Moore's law, AI will surpass humans in calculation and memories within a decade. So what happens if AI surpasses humans and it went out of control? It will be out of hand because AIs are better than us and we can't stop them. So in the book, Stephen Hawking made further discussions about AI. One of the discussion is individual in law. So should we recognize an AI as an individual in law? That means we see them as an equal life form in law. Yes. And Stephen Hawking thinks we should add a death button to every AI. It means, well, that button means it's a turn off button for the AI. So in case they want to do anything that is harmful to the human, we can turn them off. Now, this is the Moore's law. It says the number of transistors on integrated circuit chips doubles over time. And I think the number of transistors is corresponding to the speed of calculation and memories of AI. Yep. Next. In the last chapter, chapter 10, Stephen Hawking talked about how shall we mold the future. And Stephen Hawking thinks that imagination is vital in molding the future. Next. In his book, he used Einstein as an example. When Einstein was 16, he dreamed that he is riding on a ray of light. So in this case, it means that he is traveling at the same speed of light, which makes the light seems like a moving wave. So from this perspective and depiction, Einstein made the theory of relativity. Yes, and that is because of imagination. And as Albert Einstein said, I have no special talents, I'm just passionately curious. So staying curious and open to imaginations and dreaming, just keep dreaming, will shape our future, as future is just the realization of present dreams and imaginations. Next. And yes. Albert Einstein thinks that there will be a next Einstein in future generation. Can be you, me, anyone. So try to be the next Einstein. Okay, next. Okay, for extension, I would like to talk about what are the responsibilities of our generation. The book that Stephen Hawking